So if you had an average of 4.1 and you multiplied every score by 10, what happened to the average? 41. So if I had the, what would happen to the standard deviation for 10x? Yeah, so what would be the standard deviation? Let's give me a standard deviation, Jamie. Anyone? Really widespread? No, give me one that's, yeah, give me one that's got quite a big spread. Don't go a million.
8.10. Wait, 8.1.
8.1. Standard deviation is 81. So if the variance of x, what is it? That's squared. 8 8's a 64 point. Can someone do it? Oh, you go. Give me a calculator.
66, 65.6.
5.6. You okay, Georgia? So they just multiply by 10. They just multiply by 10. The variance for 10x is the original variance times by 10 squared. Because variances are all square bigger than the original numbers. If you go back to our d's and our d squareds, remember we get the d's and then we get d squareds. Why do we do d squareds? To get rid of the negatives. So everything got squared too big. So the variance is squared too big. Let's start again. No. For a moment, if I times everything by 10, it's like me and the animals got more spread out. You right? If I add to it, here's me and all the animals here, and we all move 3 metres up, out there somewhere. So what happened to the spread?
Nothing.
Yeah, and if I want to be silly, my arms all stay the same. There's no effect on the spread. So I'm a spread there as I was over there. So the sillier I can get it for you guys, the more it's going to sink into your brain. So that one is 4.1 plus 3. Standard deviation did what? Did I become more spread? Mm-hmm. No, I just added 3 to everything. So people talk about this one as being a change of origin, whereas this one was a change of scale. So the change of scale makes everything of times by bigger, and the origin just moves everything. So the standard deviation stayed the same. So what was it? 8.1? 8.1. What happened to the variance then? Stayed the same.
Same square.
Yep. So whatever it was as a square, it stayed the same. Oops, not 8.1, 65.6. So now you get a combination. We're going to change the origin and we're going to change the scale. So if you took all my numbers here, if I did here's me and my animals, and we got twice as big. By the way, we don't just get twice as big there, do we? Ready? So all got twice as big. We're all out over here somewhere. Because the 4 would have become a 8, the 3 would have become a 6. So it just takes everything and sends them off in the distance somewhere. Well, it's okay for 2. I could have half modelled that here with you. So, and then we're going to add 5 to everything. So we're going to be twice, oh, not right in there, it's right over here. We're going to be twice as spread. And what are we going to do? Increase by 5. Twice as spread, increase by 5. So if your average got twice as big, that would be 8.2. And what did we do to all the average? We added 5, so it's a 13.2. Yeah? Standard deviation, twice as spread, so the 8.1 becomes a 16.2. So if you get me here and you spread me out twice as wide, what's the only thing that affected the spread? You spread me out. Does the 5 have any effect on it? No. So they're really 16.2. The variance, original variance, 65.6. What did we do to everything? Twice as spread. Guys, that's the one everyone mixes up. So you don't times it by 2, but you times it by 2 squared.